Here I'm using the MFJ 259B analyzer to check the resonant frequency of a 40-meter dipole lying on the ground.
Looks like 5.69.
The resonant frequency of the dipole in this area is 5.69, roughly 5.7 megahertz. As we swing around, we can see the dipole just lying on the ground.
Let's see what we got. The wires running right on down over the down branches, just like the real beverage.
We're not too far from the actual beverage antenna.
The real beverage runs by this white bucket and goes in that direction. And my test beverage, a 40-meter dipole that I'm using to estimate the velocity factor with, is over here and runs kind of along this way.
I'm going to make a couple of measurements with the 40-meter dipole. Hopefully I'll get the same resonant frequency every time I check this. Knowing the resonant frequency of the dipole on the ground and the physical length of the dipole, I can calculate the velocity factor.
Okay, here's the end of my northeast beverage. And here is the end of my 40-meter test dipole. Screwdriver marks the location of the end of that antenna. Okay. Screwdriver marks the end of the 40-meter dipole. And there's the end of my feed point of my northeast beverage. As we turn around, head in that direction, the box marks the center of the 40-meter dipole where I have my MFJ set up. This looks like the minimum SWR, 5.769 or 5.77. I'm going to do a quick sweep of the MFJ up.
It would be nice if the velocity factor was the same all along the beverage. If it's not, I'll have to do some averaging of the velocity factor.
Looks like the minimum SWR point right there, 5.769.